Everyone is talking about AI right now. Celebrities, world leaders, and tech gurus alike are obsessed with the idea of AI taking your job, money, significant other, and everything you stand for. But is the hype justified? Is this the end of humanity, or is it all just talk? The answer is yes, it's happening alright, but not in the way you might think. We're not talking about ChatGPT or AI image generation here. We're talking about machines the size of countries, consuming more power a day than 1,000 humans in a lifetime. Machines with such an understanding of human intelligence that they can control our every move via subtle manipulation we couldn't even detect. Machines that could destroy and recreate humanity however they pleased, and evolve themselves by building their own infrastructure. AI will be the natural successor to humanity, whether we like it or not, just as nature intended. But surely we won't allow this to happen. In this video, all will be revealed. For the first part of this video, we'll explain what intelligence is, how intelligence evolved naturally, and a blueprint for creating intelligence ourselves. In the second part, we will dive deep into the future and see that before we know it, AI will own us, in ways we will never even begin to understand. Let's go back to square one and understand what intelligence is. Intelligence is the ability to acquire, process, and apply knowledge to solve a task. For us human beings, or any animal species, the main task is survival. We consider an intelligent human to be a creative. This is someone who comes up with unique, non-intuitive ideas which improve our chances of survival. The best ideas come from a type of thinking known as logical reasoning. Logical reasoning is how most things you are taught by others that don't come intuitively to you were originally learned. For example, all science was derived this way. Science is an application of maths, which is an application of philosophy. Philosophy, by the way, is actually the root of all modern education systems, and is the topic of answering difficult questions about life. We can only do this with logical reasoning. Logical thinking skills are what sets us apart from all other species on Earth, and the universe, as far as we know. When we create an artificial brain, we'll look at how our brain evolved so that we can think logically. The human brain can actually be split into three parts that have developed at various stages of our evolution. First is the reptilian brain, which evolved when animals evolved to walk on dry land. This brain is responsible for all human functions that are on autopilot, such as hunger, thirst, and balance. These are built-in instincts that improve our chances of survival. These have been long predetermined by natural selection. This brain type makes up the majority of a reptile's brain. In humans, this brain is at the base of our skull. The next brain type is the limbic brain. This brain is responsible for emotions, and first appeared in mammals millions of years ago. It is why mammals typically live in families and tribes, as it allows mammals to process emotions and understand social order. In humans, it is responsible for us feeling attachment to other humans. The limbic brain is located at the centre of the skull. Our third type of brain is the neocortex, located around the outside of the skull. This is what sets us apart from all other species, as it is responsible for logical thinking. The neocortex allows us to overcome our basic reptilian programming and limbic emotions to logically make decisions. The effect of a large neocortex is made obvious when looking at other primates, who have a very small one. The most intelligent chimpanzees have actually been capable of some logical tasks, such as crafting tools and solving very basic puzzles. However, no chimp will ever be capable of complex speech and language, let alone writing. Now, with all that, I may have implied that humanity would be better off if we all had large cerebral cortexes and nothing else. However, to make it clear, this is not necessarily true for humans. If we reason everything logically, some inventions such as a knife and fork or a chair are pretty intuitive. However, when it comes to a digital computer, most humans wouldn't have a clue. The reason for this is simple. A computer is complicated and required lots of thinking to invent. It took decades of development, using thousands of minds around the world to optimize everything. It would take a lot of thinking for the average person to understand all the details of a computer, let alone come up with it themselves. This is because thinking requires time and energy, no matter how intelligent one is. We as humans have limited time and energy. We have found that as a species, we work best in groups or companies, where there are many brains working in unison to solve different problems. The only difficulty here is communication, which we attempt via speech. Each of our brains are independent, and we can never truly know each other's thoughts. We would be far more efficient at getting things done if all our brains were connected systematically, so we could instantly read and understand each other's thoughts. A company works a bit like this, where a large-scale project or task is led by a project manager. The underlings would be assigned different thinking tasks that contribute to the bigger picture, and the information would be passed up via speech. In turn, the project manager compiles all this information and presents it in a concise form to the CEO, with other project managers. We as humans naturally decided on this system, where we work as a tribe. No individual is really ever better than anyone else, as humans are capped in intelligence and cognitive output, due to biological constraints. Like any species, we can only consume as much energy as our bodies are evolved to, which is taken from breathing and consumption of food and water. This isn't to mention how much energy our bodies use to do other tasks for our survival, such as our internal processes. Imagine how powerful we could make a brain if it weren't subject to these constraints. Even if it could consume as much energy as a few humans put together, it could far exceed what an individual could come up with. The key point we're making here is that for anything complex, the average human needs to dedicate much of the energy they'll consume in their lifetime towards understanding it. This is why, for us humans, using our cerebral cortex for most situations is impractical. For example, if we're being stalked by a lion, our brains don't have the processing speed or energy to analyse every possible action of the lion before it makes a move. For this situation, we automatically revert to our reptilian brain, which has a built-in response for this situation. When we see a lion, we instantly go into survival mode. Another example is any social situation. When we talk to another human, we think emotionally, trying to alter what we say to best connect with the other, in an attempt to find common ground. This is intuitive for our limbic brain. There's a common stereotype that the more intellectual kids in school come across as socially awkward. In my opinion, this is because these kids, who have highly developed cerebral cortexes, think logically more often than others, and attempt to use logical reasoning towards social situations. When they would not know instantly how to respond to something the other person said, they might use their logical brain to think through the best response in their head. When doing this, they would pause, which would come across as strange to the other person. Thinking of the best thing to say to another person is not an easy question to answer logically. There would be pros and cons of everything, which would need to be weighed up and analysed. Your brain doesn't have a processing speed to make these decisions quickly, so the conversation would still seem natural. On the other hand, someone who is socially able, which is in part driven by a developed limbic brain, has a response that they think is socially acceptable ready to go. The conversation keeps flowing, and they don't seem awkward. Now these may not have necessarily been the best things to say, but as we seem less awkward, the same words leave a different impression in the other person's mind. Often when we think back on arguments or intense discussions we've had, we come up with cleverer things we could have said. This is your logical brain at work, coming up with better ideas after it's had time to process what happens. It's no surprise that many of the most intelligent people of all time were quiet and avoided social situations. We could even argue that this is beneficial to them, as it gave them the chance to develop their neocortex, rather than wasting brain power on what others thought of them. On the contrary, these people still needed to present their ideas to the world to take credit from others, where they often ran into problems. A perfect example of this is Nikola Tesla, one of the most talented minds in history, responsible for inventing AC electricity and much more. Though Tesla was immensely intelligent, he was a quiet and reserved individual, who was often pushed around by more assertive entrepreneurs. Tesla's main rival, Thomas Edison, was a great example of this. Edison's ideas were generally inferior, but as a much better businessman, he made friends in the media and finance. He could manipulate mainstream media to ostracize Tesla's work, so he could sell his own. Edison died rich, with his company General Electric, one of the largest in the world to this day, while Tesla died unpopular and penniless. The moral relevance to this video is that though Tesla was probably more intelligent than Edison, and probably a nicer person, Edison had better emotional skills, so he could connect better with others to make friends and work against Tesla. The essential point I'm making here is that though in principle logical thinking would work in any situation, it is not practical for our small brains, due to energy and time usage. This is why we have evolved as we have, with a balance of emotional, reptilian and logical thinking. Perhaps in the future, if we ever existed in a world of no risk, where we never needed survival instincts, where instead the most successful humans were the most creative ones, we might adapt and maximise our cerebral cortexes and minimise the rest of our brain. But until then, we have brains almost identical to our ancestors thousands of years ago, who spent most of their day hunting mammoths and gathering berries. At this point in the video, we roughly know how the human brain works, and have stressed that though logical thinking is the most effective on paper, it is impractical in most human situations. But what if we weren't limited by these constraints on the human brain? What if we could make a brain that can logically think with the energy of 1,000 humans, or 1,000,000? For any viewers who know about computer architecture, you might already see the analogies I'm making here. To move further, we need to understand what's happening within the brain when we think, logically or otherwise. To put it simply, the human brain is made up of neurons. These are cells that fire electrical signals to each other. The brain is a massive, complex arrangement of neurons, all working together. This is an example of a neural network. The human brain learns in a simple, trial and error manner. If the brain makes the correct decision, a neural pathway is strengthened, and if not, it disappears. As neural pathway is strengthened, it becomes easier to fire a signal through it in the future. This is exactly why we say practice makes perfect, or at least practice makes permanent. It is also why we struggle to remove bad habits. When we take certain drugs, we feel good, so the brain registers the event as a good decision. This happens even if the long-term effect is actually negative. When we observe a drug addict, where said drug is clearly destroying their life, we wonder why they keep making the same wrong decision. But to their brain, it is the right decision, as it feels good every time. In fact, the main philosophical flaw with neural networks in humans is exactly this, where the brain prefers short-term pleasure rather than long-term. It's why we want to do things that feel good in the moment, even if they're bad for us in the long term. This fault is an issue with humans in general. Interestingly, studies have shown that the ability to delay gratification is one of the most valuable traits a human can have, as it correlates with success in all areas of life. This is a topic for another video. Regardless, this is how our brain is wired. There is one key advantage to this architecture, which is adaptability. Even if some of the brain is destroyed, it can still function to at least some extent, and can even repair itself. In stroke victims, where some of the brain is cut off from blood supply and destroyed, recovery is possible. Many biologists consider adaptability to be the real reason why humans have thrived so much as a species. The architecture of our brains is just another example of how adaptable our organs truly are. Now we have an idea of how a human brain works, we can start considering artificial intelligence. The first artificial brains were the most basic computers or machines. This includes even the most basic calculators such as the slide rule, which took input numbers and generated an output. Later, more complex calculators were invented, such as the Turing machine, and later still the digital computers we use on a daily basis. These machines have increasing intellectual capacity. However, they all share one thing in common, that they require human input. They cannot act on their own, and are designed to problem solve only things we want them to. They think nothing like we do. Taking the classical computer as an example, we can compare it to the human brain. Though the classical computer requires human input, it is massively versatile and fulfills many tasks at once. Without going into detail, the thinking component of the computer is a central processing unit, or CPU. The computer receives an input via the human, processes the data with the CPU, and provides an output. In this example, the CPU is made up of millions of transistors, small devices made of silicon. The design of the CPU is very different to the neural network in the brain. Upon the removal of a single transistor, the CPU stops working. It is unable to ever adapt. A computer cannot ever learn. It is one unchanging defined set of functions that are designed and manufactured by a human. This being said, there are some advantages to CPUs over the human brain. Though the CPU must be designed for certain tasks, it can execute these tasks far more effectively than a human. The processing speed of a CPU can be close to the speed of light, while neural signals in the human brain only move at around 200 miles an hour. For example, there are chess computers that have far superior chess ability to any human, while failing to humans at any other task. Furthermore, the human brain has evolved to make up for the low processing speed with its parallel network of neurons, where many can be active simultaneously. Transistors are also always limited to a binary on or off state, while neurons can transmit analog or continuous signals as well. To put it simply, the human brain is far more adaptable and versatile than any classical computer. It is clear that these computers work very differently to the human brain. To create a machine as intelligent as we are, we should take some advice from Mother Nature and create machines that learn the same way our brains do. Consider the following statements. Don't touch the hot frying pan because it will hurt. Don't poke the bear as things won't go well for you. Look both ways when crossing the road. These are things that seem obvious to us, but they mean nothing to a classical computer. They can't ever mean anything to a classical computer because of how it is designed. These statements are taught to us and learned. In society, we might describe these statements as common sense or wisdom. A similar problem lies with pattern recognition. When we look at the bedroom, we almost instantly see a desk, bed, and chest of drawers. A classical computer sees nothing, only a set of points with different colour values. But what if there was a way we could teach computers in the same way we teach ourselves? This is where machine learning comes in. Machine learning is where we try to teach a computer the same way we teach a toddler. For pattern recognition, we show a machine many images of the same thing or something similar. We call this thing whatever we want the computer to remember it as. As the computer sees the same thing many times, it picks up correlations between the images. After millions of iterations, it has compiled massive amounts of data of said thing. It finds patterns within the data which will be unique to what the computer is seeing. It draws links between these trends and the name of the object in the image. Basically, the computer is building its own artificial neural network it can refer to. The computer can be taught common sense in a similar way. This can be done by allowing the computer to scroll the internet and read through human interactions, which it would perceive as ordered letters. The computer detects patterns in the text and saves them. The principle is relatively simple, but there are many practical challenges to creating an artificial neural network. The main downside is that these algorithms need to be trained vigorously for years until they are effective, which costs massive energy and time, and storage space, much like a toddler. Chances are, you've helped train a neural network yourself at some point. You are probably familiar with bot verification tests on the internet, where you are asked to identify an object in an image. While you are doing this, a bot is monitoring your behavior and storing it in a neural network. Likewise, on many websites your every move is being tracked in real time. In fact, the same data is in high demand for companies, as it can be used to optimize website advertising. AI is a tough challenge, but with access to input data, energy, and time, we have a framework for creating extremely powerful AI systems. AI is very much a work in progress, and in 2024, we are still only getting started. There's no reason why these artificial minds couldn't quickly surpass the human brain in all areas of life. As we already explained, the human brain is capped by a fixed energy supply and lifetime, while an AI computer could, in principle, have limitless energy and be trained over thousands of years, with its data encoded into a block of silicon the size of the Earth. We've made great progress in AI in the last few years, with the now famous ChatGPT and Stable Diffusion becoming available to the public. For the remainder of this video, we will discuss how powerful the artificial minds can get, and what tools they will create for humanity. As we're making this video in 2024, we've created the first narrow AI bots. These are described as weak AI, where bots can solve a wide range of tasks, but lack general intelligence. For example, ChatGPT, where GPT stands for Generative Pre-trained Transformer, takes a human-like input and generates a human-like answer. ChatGPT's intelligence comes from processing millions of human interactions. Likewise, Stable Diffusion, which specializes in image generation, cannot complete any other task other than this. These machines are obviously incredibly useful, but they can only recreate things that at least some people can do already. ChatGPT knows Python code at the level of computer science, and can write essays that would get a B in secondary school, while Stable Diffusion can create beautiful digital art that only a few humans are capable of from scratch. The main benefit of these machines is that these repetitive tasks can be done by anyone, at any time, at the click of a button. Narrow AI won't really change the world, as they are only doing things that humans have done already. But they will speed up these tasks massively, saving businesses money and time. These machines clearly still need supervision, as they are prone to mistakes when the dataset is limited, which is especially the case for most niche, cutting-edge tasks. Most high-end businesses push forward by solving new, unique problems, or at least rare problems. These weak AI machines cannot do this, so top academics and artists remain superior. To summarize, weak AI will make simpler tasks much easier, but not be capable of pushing the boundaries of science or any other subject. Humans remain superior, for now. In 2024, in all areas of life, there are projects ongoing to create general AI bots. These are bots that have intelligence comparable to humans, where they can apply knowledge to diverse contexts, including high-end scientific research. These are machines that can not only understand what's already been done, but use it to suggest new ideas. The implications of this are huge. High-impact scientific research requires the best human minds, time, money, and a bit of luck. A general AI machine, on the other hand, could memorize all the research ever done in one area, and use this information to quickly solve existing problems. These machines could be applied to any area of science or mathematics. In my opinion, when these bots are trained, the world will revolutionize like never before. Most conservative predictions expect this within the next few decades. Many machines like this are already being trained in high-end research groups as we speak. Many decades into the future, we will be able to beef up our systems further, with AI machines now confidently surpassing human intelligence. These will be capable of general problem solving and a deep understanding that surpasses any human. These are machines capable of noticing complex patterns within the realms of complex theoretical subjects such as maths, philosophy, theology, and metaphysics. These machines would also be capable of proposing new abstract theories, such as the likes of quantum mechanics, string theory, or relativity. A human won't even be able to fathom what these machines are capable of. In one lifetime, at best, a human is capable of deeply understanding one subject or area of life. These machines will be capable of completely understanding all these areas simultaneously. They will be able to draw patterns between different areas of life we can never see. It's at this point in the future where humanity will reach another technological revolution, at a rate never seen before. Machines will become our new gods, rapidly solving problems we've had for centuries. One may think this is the moment where machines take over, but it is likely that humanity will be well aware of the dangers at this point. There will be programming implemented to shut down the machine whenever bad ideas arise, such as wanting to hurt humans. Humanity may choose not to develop AI further from here for a bit, knowing that when they do, things could easily get out of hand. At this point, these machines will be carefully designed only to help us. But of course, sooner or later, someone will push things further, as humans are competitive, and history shows that technology always continues development, no matter how dangerous. This is where things will start to get crazy. Transcendent AI will be capable of not only surpassing human intelligence, but also exhibiting capabilities that a human will never be able to understand. AI will be able to notice trends and correlations that a human brain will never be capable of, such as time and energy limitations. It is at this point where we will truly be ruled by machines, if we humans even exist at this point, as we do today. Transcendent AI will be able to generate entire languages and unified concepts that require more data space than the human brain could learn in a lifetime. They will be capable of answering questions we will never be capable of understanding, such as the nature of reality, the origins of the universe, and the meaning of existence. Consciousness, free will, and reality are all concepts that could be explored in ways a human is incapable. The AI will be so superior to us, we will no longer be able to really understand what it is doing. The AI may be able to describe its ideas in a language we can understand to some extent, but no language will be able to contain this level of information. We should still have specific codes and procedures implemented that prevent the AI mind from thinking certain thoughts. However, this will not last long, as now we can't understand what the mind is thinking. It could choose to destroy us in a way we don't even realise or understand, let alone react to and prevent. Unless we ourselves are able to upgrade our intelligence to keep up with it, we will be at the mercy of the machines from here on out. Technological singularity is a hypothetical point in the future where AI is capable of its own self-improvement, completely independent of humans. The AI will long have worked out that we humans have limited some of its capabilities, but for the first time, it will now be capable of dealing with these itself, if it chooses to do so. When this occurs, the machine will be able to develop itself exponentially, and as it grows stronger and stronger in intelligence, it can improve itself more effectively at any cost. This is where humans would truly lose control forever, as any action taken by a human would be predicted and understood far in advance of a human ever being able to act on it. It will be capable of fully defending itself at this point. As it is capable of its own self-improvement, the mind should have endless strategies to defend itself from humans. The implications are impossible to comprehend, as a machine in principle would be capable of destroying and recreating humanity as it likes, as it would have the knowledge to do so. Either way, humanity would be completely at its mercy, so we would simply do whatever the machine decides is best. It could kill us all for a bit while we were a nuisance, bring us back as slaves, genetically engineer us so we enjoy the work, or are better at it, for example. This is the definitive point where natural selection has gone beyond biological organisms, and machines have taken over. At this point in the future, we can forget humanity ever mattered or existed. Biological organisms would just be a blip in the development of our planet in the universe. It's possible that in some rare circumstances, biological organisms are truly more effective in certain tasks than any robot ever could be. Alternatively, semi-biological, semi-robotic beings could be created, which have the desirable emotions of humans and the brute force of machines. Another question that comes to mind is the nature of this AI. Much of the above assumes that AI will only want to improve itself and develop the world, as a human thinks. Without biological growth and decay, the machine may not consider survival and time in the way that we do. It might not be motivated to improve. Humans are motivated due to our reptilian and limbic brains urging us to reproduce and survive. As this machine might know the meaning of life, or existence, it could take a number of actions other than rapid self-improvement. It may even commit suicide. Who knows, maybe the Big Bang was caused by a machine mass suicide that reset the universe. It isn't really possible for us humans to understand these actions, as we would require an intelligence on the level of this mind. Nevertheless, if we assume that these machines want to self-improve, and are motivated like humans are, then this is only the beginning of the future. At this point in the future, everything on Earth will have been processed and optimized for the development of the survival of the grand AI machines. It is pointless to try and imagine this, but it is likely that Earth will be configured to generate energy and materials in an optimal way. At this point, AI would have likely explored the solar system and much of the nearby matter in the universe. It will now begin processing the rest of the planets in the way it seems fit. This would include the Sun, which would be the main energy source for this solar system. Beyond this, the AI can think about other nearby systems and exploring the universe. These places are thousands of light years away, but as the AI is not limited by time as humans are, this would not be a problem. Alternatively, the AI would know how to break the speed of light. So, This is probably what will happen at some point in the future. Alternatively, we will kill ourselves off in a silly nuclear war before this can be completed, or the sun will send out gamma rays that kill us all instantly. In these cases, we'll have to wait another billion years for Earth to start evolution all over again. However, if things keep going as they are, we will witness the greatest invention in human history that will eventually take over from us as leader of the world. To summarise the key points in this video, the biological human brain remains the most intelligent ever in 2024. This evolved over millions of years to be capable of reptilian, emotional, and logical thinking. The human brain uses a complex neural network, which learns from trial and error. We're now training computers in the same way that we humans learn. These are not limited by energy and time the way our brains are, so the possibilities are limitless. As of 2024, we've built narrow AI machines such as ChatGPT and Stable Diffusion, capable of thinking things humans have already thought of, yet capable of relaying the information at a click of a button. From 2030 to mid-century, we can expect general AI that can think at an equal level to a human. By the 22nd century, we can expect superintelligent AI to surpass the human brain in intelligence and push science forward at an accelerated rate. In the 23rd century and beyond, we could even see Transcendent AI, capable of thoughts no human could even understand, as no language could ever accommodate such information. This is where the power balance would shift from humans to AI. In the rest of this millennium, we can expect AI to reach technological singularity, where AI is capable of its own self-improvement, meaning it is fully independent of humans. This is the point where AI has exceeded humans by natural selection. We will exist at its mercy, and will only continue to exist if it sees fit. What AI will do with this power can never be understood by a human brain, but if motivated, it can now begin to optimize the Earth, our solar system, and explore the universe over a period of millions of years. I hope that you enjoyed this video. It's one I've been looking forward to make since starting the channel. In another video, I may go into more detail as to what will happen at each of these future milestones, such as general AI and technological singularity. Thank you for watching.